Hello, College Algebra 2. Mrs. A here. We're going to continue our notes with 9.2 Compound Inequalities. This first part is just a review of yesterday as a refresher. So yesterday we took a look at a couple examples, just writing two inequalities together using and or, and we talked about and. Please note at the bottom down here, it says and corresponds to an intersection, while or corresponds to a union. So we're just going to take a look at and here. This is the stuff that you guys wrote down on the board yesterday, just talking about specifically the intersection here. All right, intersection is and, so you guys can see this upside down U and right here. Those two go together. All right, and today we'll take a look at or using union. So if we've got the regular like wide U shape here, that represents or, and that's where we're going to take a set of elements in each one of the inequalities and put them together. All right. So here's just a couple of examples where we're using just numbers, no variables, no expressions, just very basic here. So this first one here is asking for the intersection, and remember intersection is and, okay, so it's where they overlap. So looking at these two sets here, we have 1, 3, 5, and 7, 2, 4, 6, 8, and 10. So we take a look, we've got a 1, we've got a 2, we've got a 3, we have 4, 5, 6, 7, 8, and 10. So because the two sets have nothing in common, there's no solution. Therefore, we say the solution is the empty set. And this is very similar to 9.1, those first two examples that we did, where one was all real numbers and the other one was no solution. So the same thing can occur here. So if we take a look at the second set here, we've got 1, 3, and 7, and 2, 3, and 8. So you will see here, obviously, that the 3's are what both sets have in common. So our solution set would just be 3. You guys already took notes on that yesterday. This is just going through a very basic example like we did. Graphing where they overlap. Now we should go back to that for Carly. So Carly, this one here, x is less than 3, so we have that nice parenthesis here. X is greater than or equal to -1. Put in that bracket. They didn't put these solutions in set builder notation, so if you guys wanted to do that, you would have your brace x such that, and then you would start with -1 is less than or equal to x, which is less than 3, and then end with your brace as well. Okay, so if you don't want to do the interval notation, change it into set builder notation. And just another example of an and compound inequality. Just going to kind of go through this quickly here, you guys, because we already did this yesterday. All right, here we go. So compound inequalities involving or. And if you guys need more time to write this down, just pause the video. So for the first one, it's the same as when we're solving with and. You need to solve each inequality separately. And then you're going to graph each solution set to each of the inequalities on a number line. And take the union of these solution sets. So underneath there, you might want to star that or underline it. Remember, union means what is in either set. You just put it all together. Okay, so I like to remember this for union, which is your or. Union starts with a U, so that you're going to use the U symbol. Intersection is for and we want the upside down U for that. Alright, so let's take a look here. We're going to find the union of the sets. So we've got 1, 3, 7, 8 and 2, 3, and 8. This should look familiar here. So what we are looking for, okay, so sorry about that. The solution here is each element of the first set and each element of the second set. However, we're not going to represent any elements more than once. Namely, the elements 3 and 8 should not be listed twice, and you guys already know that. Okay, so union is or. Basically, we're just going to scrunch it all together and make sure we don't repeat any numbers. So make sure they're in order from least to greatest, and you're not repeating any values. Alright, so here's our example of OR. We've got 2x minus 5 is less than or equal to negative 11, or 5x plus 1 is greater than or equal to 6. So the first thing you guys need to do is solve each one separately. So we're going to add 5 to both sides and divide by 2 for that first inequality. And the second one, we're going to subtract 1 and divide by 5, which this just takes you through here. And same thing here. So then we're going to take the two solution sets and graph them on our number line. So you can see here for that first inequality, we got x is less than or equal to negative 3. Make sure that you have a bracket on that going to negative infinity or to the left. X is greater than or equal to 1, another bracket here, but we're going to positive infinity this time because x is greater than. So when we combine these two on the same number line, this is what it should look like. And once again, you guys, you don't have to graph 3 separate number lines. You can go ahead and just keep one number line and put them both on the same number line. Here they've written this in interval notation. So you can see here we're going from negative infinity to negative 3. Put that bracket. Since it's OR, we have to use the union. And then we're going from 1 to positive infinity here. So once again, make sure it's a bracket followed by a parenthesis. This last one here is just a word problem kind of tying everything all together. So we have parts for an automobile repair cost $175. The mechanic is charging $34 per hour, and you receive an estimate for at least $226. And the most it could cost for fixing your car would be $294. What is the time interval for hours that the mechanic will be working on the job? So you're just going to basically set yourself up a compound inequality. You know that the mechanic is going to charge at least, this is his estimate, $226 to $294. Okay, parts for your car aren't going to change. That's going to be $175, but the mechanic is charging $34 per hour, and we're not exactly sure how many hours he's going to need. So to set up this compound inequality, we're going to have 226 on the left-hand side. We're going to have 294 on the right-hand side. And then in the middle of our compound inequality, we want that 34x, because we're going to let x equal the number of hours plus the $175. So I think this is here on this side, right? So we just talked about that. It doesn't matter if you want to write it 175 plus 34x, or if you want to write it 34x plus 175. Really doesn't matter, completely up to you. Here's our compound inequality, and we are using AND because it can range between these values. All right, so it can be, remember, they estimated 226 low end, 294 high end. And then you guys just have to solve it. So we'd start by subtracting 175 from both the 226 as well as the 294, and then you're going to divide everything by the 34. So we get that it's going to take anywhere from an hour and a half to 3.5 hours in order to fix our car. All right. If you have questions, I guess refer back to the video, talk amongst yourselves, and if you're really stuck, send me an email, I'll send you guys some links. Have a good day.